Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, paper 2. In the last lesson, we have discussed question number 1 from the same paper, and for the solution of question 1, you can go to the channel and you can check for October-November 2022, paper 2, part 01. Then you can find the solution of question number 1. And today's class, we will start from question number 2, and we will try to cover at least 2 or more than 2 questions in today's lesson. Let's study together. Let's improve together. For question number 2, it is given to us the engine of a toy rocket pushes gases vertically downwards, and this results in the rocket accelerating vertically upwards from the ground. The rocket starts to move from rest at t is equal to 0. The variation with time t of the vertical velocity v of the rocket for the first 0.30 seconds of the flight is shown in figure 2.1. And here we have vertical velocity on y-axis and time is given on x-axis. It is also given to us a resistance we can assume in this case is negligible. For part A1, we need to show that acceleration of the rocket is 55 meters per second per second. This question is quite straightforward one. We need to find acceleration. That vertical velocity against time graph is given to us. So the gradient of this graph, simply we can say gradient of this graph, VT graph, this is equal to acceleration. So simply we need to calculate gradient of this graph. And the best way to calculate gradient is we can take 1 point here and we can take 1 point here and we can find the gradient. At this point, so we have 15, so this will be 16 and this will be 16.5 meters per second per second. So we can find out in this case value of acceleration that will be equal to the final velocity, that is 16.50 minus initial velocity divided by time taken. So in this case time taken is 0.30 seconds because time is given to us. And now if we simply divide this one, our final answer up to 2SF, this one will be equal to 55 meters per second per second. And this is how simply you can answer this question. For the second part, we need to state an expression for the resultant force F experienced by the rocket in terms of thrust force and weight of the rocket. So first of all, let's try to sketch the shape of the rocket. So simply you can imagine that this one is the rocket and rocket is pushing gases downwards and the rocket is moving vertically upwards. So this one is the rocket. So if we draw the free body diagram of this rocket, one force is acting down, that is weight of the rocket. And the force acting vertically upwards, this force is thrust force. So this one is T. As this rocket is accelerating vertically upwards, it means T is the bigger force. So simply in this case, we can write down the resultant force means F net. That one will be equal to T minus W. So that's all what you need to write down. Now let's go to the next part. For the next part, we need to calculate mass of the rocket. That value of thrust force is given to us in the previous part, that is equal to 16 newtons, and value of acceleration we have calculated in part A1, that was equal to 55 meters per second per second. 55 meters per second per second. So simply we have to use these informations and we can calculate mass of the rocket. So simply we can use this. So in this case we have F net. So we have F net, that is equal to thrust force minus weight. So this is weight. So F net we can write down this is equal to MA, and thrust force we have this is equal to 16, and the weight we can say this is equal to mg. So from here we can write down MA plus mg, this is equal to 16. So this is equal to 16 newtons. We need to calculate mass, so we can take mass out. This one will be equal to A plus G, and this will be equal to 16. So we need value of m. So simply we can say m, this one will be equal to 16 divided by A plus G, and we can plug in values of A and G. So we have 16 and this will be 55 because value of A and G is equal to 9.81. So if we solve this one, the value of mass will be equal to 0.25 kilograms up to 2 SF. So this is our final answer. So we can write down final answer is 0.25 kgs. So this is how we can answer this question. For this question, you will get 1 mark if you have written the first step. If you have written this step, you will get 1 mark, that is C mark, and the second mark is an answer mark you will get if you have got the right answer. So this is how marks will be awarded, and this question has only 1 mark. This is B mark. For part B, it is given to us at time t is equal to 0.30 seconds. A small piece of metal separates from the rocket. We need to calculate for part B1 the height of the rocket above the ground at t is equal to 0.30 seconds. Then this question is quite straightforward one. There are different ways to answer this problem. One way to answer this problem is you can simply calculate area under this graph because we have the time, this time, so simply you can calculate this area, and that is equal to the displacement of the rocket, and displacement of the rocket in this case is equal to height of the rocket because rocket is just moving vertically upwards. So this is one way you can calculate area. In this case, this area is representing the displacement, or simply we can say this area is representing height of the rocket. So this height is equal to displacement. So simply you can calculate area under this graph. So we can say height will be equal to 1/2, we have 16.5, means value of V at this point 16.5, and the time is 0.30. If you multiply this one, you will get, in this case, your answer will be equal to 2.475 meters. Up to 2 SF, we can say this is 2.5 meters. So this is one way you can calculate. So I can say this is one way to calculate. And the alternate method is you can use the formula. You can use S is equal to UT plus 1/2 AT square. So in this case, initial velocity is 0. So it means this term is equal to 0. So we can say this is 0. Plus we have 1/2. A is 55. Acceleration of the rocket we have calculated, that was equal to 55, and the time taken is 0.30 second, square of this. If we solve this one, our answer will be equal to 2.5 meters. So this is another way you can calculate height of rocket. Height of the rocket in this case is equal to displacement of the rocket because rocket is just moving in one direction. So this is how you can answer this problem. For the second part, we need to find the speed at which piece of metal strikes the ground. So the best way to answer this problem is we can sketch first of all. So this one is over rocket. So this one is rocket. So simply we can draw this beautiful rocket like this. And it is given to us the piece of metal leave this rocket at this time. And the speed of rocket at that point is 16.5 meters per second. 16.5. So it also means that the piece of rocket that leave this rocket, that also has the same speed. So we can say the initial speed of piece of metal is 16.5 meters per second. And question is asking us to calculate the speed of this piece of metal when this will strikes the ground. So we can say when it strikes the ground at this point, we need to find out what is value of V. But if you look at the motion of this rocket and also the motion of this piece of metal, when it will separate from the rocket, it will not just go down. Actually, this one will go vertically up and then it will come down. So this is how it will move. So this is the motion of piece of metal. But in this case, we have already calculated the height of the rocket at that point. Height of the rocket we have calculated, that is equal to 2.5 meters. So it means that this one is the displacement of piece of metal. So this is the displacement, and we have the initial velocity, and acceleration of this piece of metal will be equal to 9.81 because this is in free fall. There is no any air resistance. So we have these informations and we can find out value of V. So as acceleration is constant, so simply we can use 2as. This is equal to V square minus U square. So we can simply say in this case v square. This one will be equal to u square plus 2as, and simply we can plug in values and we can find out value of v. So we will take square root on both sides. So we have to take square root on both sides. And in this case, also we need to understand we are taking downward as positive. So we are taking downward as positive. If we take down is as positive, it means this displacement will be positive. And this acceleration also will be positive. But the initial velocity, this one will be negative. So signs are very important. Signs are very important. So this is u, and value of u is minus 16.5 square. We have plus 2, and time we have value of a, that is equal to 9.81. This is positive. S is also positive, that is 2.5. Now simply we can solve and we can find the answer. So signs are very important, so you have to be careful with that. In this case, acceleration is positive because we are taking down is positive. So u is negative, displacement is positive. Now simply we can solve for v. In this case, answer will be 18 meters per second when it will strike this ground. So the velocity at this point will be 18 meters per second, and our answer will be positive because we have taken down is positive. It is telling us that this piece of metal is moving downwards when it strikes the ground. So this is value v, and this is how we can calculate. So our answer for this question is 18 meters per second. For third question, part A, we need to state the principle of moments. And principle of moments simply tells us if any object is in equilibrium, moment about any point has to be equal to 0. Simply we can say sum of clockwise moments has to be equal to sum of anti-clockwise moments about any point if object is in equilibrium. Now let me show you the answer, how you can write down your answer. This is how you can write down your answer for principle of moments. So simply you can say sum of clockwise moments has to be equal to sum of counterclockwise moments, or you can say anti-clockwise moments about the same point, means about any point. If you choose on the object or out of object, resultant moment has to be equal to 0 if object is in rotational equilibrium. So this is how you can answer this question. For part B, it is given to us a hollow plastic sphere is attached at one end of a bar. The sphere is partially submerged in water and the bar is attached to a fixed vertical support by a pivot P, as shown in figure 3.1. So you can see here we have sphere here. It is placed inside water and this is partially submerged, and other side is placed at a fixed support. And question is, and the weight of the sphere is given. The sphere has weight this much, and the distance from P to the center of gravity of the sphere is given, that is 0.29, and assume that weight of the bar is negligible. Mean this bar has no weight. Mean this bar, it has no weight, is negligible. And we need to calculate moment of the weight of the sphere about P, means the weight of this sphere. So simply we can draw arrow for the weight. Weight is acting vertically down. So this is W, and the magnitude of W is given, that is 0.30 Newton. We need to calculate moment due to this force about this point. So simply we can draw in this case. So this is line of action of the force, and we can also draw a line here. And this is the distance, and this is the perpendicular distance between line of action of the force and this pivot, perpendicular distance. And this perpendicular distance in this case is equal to 0.29, and this is cosine. So this is cosine. So we can say this distance is equal to 0.29 cosine of 40 degrees. So we have the value of t, and the force is given. So simply we can say in this case moment, m for moment, this will be equal to force time perpendicular distance. Force in this case is weight, and the perpendicular distance from the pivot is given, that is equal to this much. So simply you can plug in these values and you can find out value of moment. And distance is 0.29 cos of 40 degrees. And if we solve, our final answer will be 0.067 Newton meter. So this is our final answer for this question. So this is how you can calculate. So you need to visualize this one. You can draw these lines, line of action of the force, and this is the pivot, and this distance you need to find out. And that is equal to 0.29 cosine of 40, because this is horizontal component. So this is how you can answer. For part C, it is given to us the system shown in figure 3.1 is part of a mechanism that controls the amount of water in a tank. Is a practical application how we control amount of water in a tank. Water enters the tank and causes the sphere to rise. This results in the bar becoming horizontal. Figure 3.2 shows the system in its new position. In this position, the rod R exerts a force to compress a horizontal spring that controls the water supply to the tank. R is positioned at a perpendicular distance of 0.017 meter above P. Mean this perpendicular distance is given to us. And question is asking us for part C1, question is asking us to calculate the spring constant of spring. Means spring constant we need to calculate. And in this case, force applied is given to us, and force applied is equal to spring force. And on x-axis we have the compression. So x is compression. So we need to calculate spring constant. So spring constant in this case simply will be equal to the gradient of this one, because spring constant is equal to force divided by x. X means the compression. So we can take 1 point here and we can take the value of compression. So at this point you can see the value of the force, that is equal to 21. This is 21. So we can take 21, the force, divided by compression. Compression is equal to 10 millimeters. So this is 10 millimeters, and we can solve this one. Our final answer will be 2100 newtons per meter. So this is our final answer up to 2s. So this is how you can find the answer, because K is equal to F4x, means the force divided by extension. In this case is compression. So extension or compression. So you can simply divide and you can find the answer. So this is our final answer. For the second part, it is given to us at the position shown in figure 3.2. The system is stationary and in equilibrium. The radius of the sphere is given to us, and it is also given to us 26% of the volume of the sphere is submerged. 26% volume of the sphere, very important one. And density of water is given to us. We need to find out upthrust, means the upthrust is equal to this one. So this is we need to show by calculations. So we need to calculate upthrust. So the best way to start is we can simply write down first of all upthrust. So let's say upthrust is equal to F. So this is the upthrust. We can also say U here, mean this is the upthrust. Upthrust is equal to rho times G times volume of fluid displaced. And this is density of the fluid, and this is volume displaced. Fluid displaced means volume of fluid displaced. V is very important. Volume of fluid displaced. So this is how you can write down formula for upthrust, and this formula you can also find in formula list. It is also given to us. Now simply we need to plug in values. Density of the fluid is water, so the density of water is given, so we can write down this is density of water. This is 1 times 10 to 3 means 1000 kgs per cubic meter. Value of G is 9.81. Then the volume of sphere, so volume of sphere will be equal to 4 by 3 pi r cube, pi r cube. And only 26% of the volume of the sphere is submerged. 26% means 0.26. So this is the volume of the fluid displaced. Now simply we can plug in values and we can calculate the final answer. Value of R is given, radius is given, that is 0.048. We need to take cube of this one and we need to multiply by 0.26. If we multiply, our final answer in this case will be equal to 1.18 newtons. So this is value of upthrust acting on the sphere. So this is how you can calculate. So this is the important part you need to understand. 26% of the sphere is inside the fluid, and that is equal to volume of fluid displaced. So next time they can trick you in a different way. So you need to understand which volume you have to write here. Volume of fluid displaced. Volume of fluid displaced. For the third part, we need to take moments about P and we need to determine the force exerted on the spring by the rod R. So first of all, we can draw the forces acting. On the sphere, there are two forces acting. One is the weight that is acting downward and the value of the weight is 0.30 newtons. Then there is upthrust that is acting on the sphere as well, and the value of upthrust is 1.18. We have just calculated in the second part. And there is a force by the spring that is pushing this rod this way, and the spring force is equal to the force exerted by the rod. So we can say that force is Fs. So the spring is pushing this one this way because the rod is pushing to the right and spring is pushing to the left. So this is the force. Now simply we need to take moment about this point and we can calculate value of Fs. So due to this one, moment will be clockwise, mean due to this force, moment will be clockwise. Moment due to this one will be anti-clockwise, and moment due to this one also will be anti-clockwise because this is the perpendicular distance, so the force is pushing this way, so the moment will be anti-clockwise. Now simply we need to equate these moments and we can calculate value of this force. Due to upthrust, the moment is clockwise, so we can say 1.18 times the distance, that is 0.29. This one has to be equal to moment due to this weight 0.30 and the distance is 0.29 from the pivot plus moment due to this one, that will be equal to F times 0.017 because line of action of force is this one and the perpendicular distance between line of action of force and the pivot, this is the perpendicular distance, and that is equal to 0.017. Then now we can solve this one for F. If we solve this one for F, our final answer will be equal to 15 newtons up to 2 SF. So this is our final answer up to 2 SF. This is what question is asking you to calculate. So our final answer is 15 newtons. For part 4, we need to calculate the elastic potential energy of the compressed spring. EPE we can calculate using different ways. One way to calculate EPE is 1 over F times X. Value of force we have already calculated. F in this case, F is equal to 15 newtons. We have just calculated in the last part. Now we need to calculate value of X, and this graph is given to us and we can directly read from the graph. So if you read from the graph, that one will be equal to 7.2 millimeters because when the force is 15 newtons, compression will be equal to 7.2, and we can use these values and we can find out value of elastic potential energy. So we need to simply plug in values. So we have 1/2 and the force is 15 and compression is 7.2 times 10 to minus 3 because this is in millimeters. And if we solve this one, our final answer will be equal to 0.054 joule. So this is the final answer. But you can also calculate elastic potential energy using this formula. You can calculate EPE. This is equal to 1/2 kx square. We have already calculated value of k. Value of k was 2100 and x you can read from here, that is equal to 7.2 times 10 to minus 3 square, and you will get the same answer. So you will get 0.054 joules. And value of x you can also find out using the formula. For example, if you need to find out value of x when the force is 15 newtons, you can divide by value of k. K is equal to 2100, and you can also find out value of x. So this is another way to calculate value of x if you don't want to use the graph. So you can also use the formula. You can find out value of x and your answer should be close to 7.2 times 10 to minus 3. So this is value of x in meters. So this is how you can answer this type of problems. I hope this question is clear to you.